Hi, it's Jo Karen Hudson speaking. Today we're going to talk about functional notation. A relation is a set of ordered pairs. So we have a set, and we're going to put some ordered pairs in it. 2, 0, 0, -7. Maybe let's put 3, 5 in there. Now, a function is a special type of relation in which no x values are repeated. So our x values were 2, 0, and 3, and we didn't repeat any of those, so we actually have a function there. The domain is the set of all x values, and the range is the set of all y values. So we want to determine if the relation is a function and give its domain and range. So let's look at the x values first. We have -3, 0, 1, 3, and 5. In other words, the domain is -3, 0, 1, 3, and 5. Did we repeat any of them? No. So yes, this is a function. The range is the set of all the y values. So the range is -3, -2, 7, 9, and -1. -2, 7, 9, and -1. It is not necessary to list that -1 that has been used twice. We only list numbers once when we list elements in a set. Let's look at the next example. Is this a function? Let's see, what are the numbers, what are the elements of the domain? The domain is 1, 2, 3, 4, and 5, and it's real easy to tell that those are all different, so yes, it is a function. The range, what's in the range? What are the y values? All of the y values are 10, so the range is easy. It's 10, and it's only necessary to list it one time. This looks a little different, and this one is not used, so let me just mark it out. I didn't realize I had one that wasn't being used there. Uh, when I'm listing the ordered pairs, let's see, -1 and 5 go together. -1 and 5 go together as an ordered pair. And 2 goes with -2. And 5 also goes with -2. And then 11 goes with 5. And 11 goes with 11, is paired up with 11. So we actually have 11 paired up with two different, we have an x value used twice, so this one is definitely not a function. The elements of the domain, or the x values, are -1, 2, 5, and 11. And the elements of the range, let's see, 5, -2, -2 is used another time, 5 is used another time. Okay, so the elements of the range are 5, -2, and 11. The vertical line test and evaluating functions. The graph of a function can be intersected at most one time by any vertical line. This is called the vertical line test for functions. Use the vertical line test to determine whether the graph is a function and then state the domain and the range. So we want to use our vertical line test. How many times does a vertical line, whoops, didn't do a very good job there. How many times does a vertical line hit that graph? Well, only one time. Let's do it again. How many times does a vertical line hit that line? Only once. Let's do it again. How many times does a vertical line hit the function? Only once. This is actually a function because a vertical line only hits the graph in one spot. This is a function. Now we want to talk about the domain and the range. Okay. going to erase those so that they don't get in our way when we're talking about the domain and the range. We said it was a function. The domain is how far left does the graph go. If I extend this, you see it goes further and further to the left, all the way to negative infinity. And if I extend this, you see it goes further and further to the right, all the way to positive infinity. When we talk about domain and we're looking at a graph, we're talking about how far left and how far right the graph extends. When we're talking about the range, we're talking about how low and how high the graph extends. So looking at this again, how low does this go? Does it keep on getting lower and lower and lower? Yes, it does. So it goes all the way down to negative infinity. How high does this go? Keeps getting higher and higher and higher, doesn't it? All the way to positive infinity. Okay, we have another graph, and it's a parabola. And I'm going to do the vertical line test first to see if it's a function. Let's see, a vertical line hits it once. Vertical line hits it once. Vertical line hits it once. This is actually a function. And then I'm going to erase those and talk about the domain and the range. You see, this is a parabola, and as this continues to go down, it continues to spread to the left and to the right. How far left does it go? It's spreading out wider and wider and wider. How far left? To negative infinity. How far right? To positive infinity. When you talk about the range, you're talking about how low and how high. How low does this go? Keeps going further down, down, down. Goes all the way to negative infinity. How high does it go? Goes all the way up to here. And where is here? It's right at 6. So it goes to 6 and it includes that point. So we say it goes from negative infinity to 6. Now we have another parabola, and we'll do the vertical line test first to see if it's a function. Vertical line test. How many times? Uh-oh, it hits it twice. It's not a function. It's a no. I'm going to erase that, and then we'll talk about the domain and the range. The domain is how far left it goes and how far right it goes. How far left does this go? Well, it just goes to 2, doesn't it? Goes from 2, it includes that 2. How far right does it go? Further and further and further to the right, further and further and further to the right, all the way to infinity. How low does it go? And you have to imagine that these arms are spreading. They're spreading as they go further and further to the right. It's getting higher and higher and higher. I don't really have it looking like that, do I? But it's getting higher and higher and higher, and it's getting lower and lower and lower. It's continuing to spread up and down. So how low does it go? To negative infinity. How high does it go? To positive infinity. Now we have to determine whether this graph, if we're not given the graph to look at, we have to graph it ourselves. So we're starting with y is equal to 3x plus 5. And you remember y is equal to mx plus b. The b here in this case is 5, and the m is 3, but we need a rise over a run, so we'll say it's 3 over 1. So b is 5, and then it rises 1, 2, 3, and runs 1. So this is a line. And we want to give the domain and the range. Actually, it doesn't ask for the domain and the range. But you can see that how far left it goes, negative infinity, how far right, positive infinity, how low, negative infinity, how high, positive infinity. Didn't ask for that. Okay, on functional notation. When we use functional notation, we replace y with f of x. You see they just wrote f of x here instead of y. So we'll start off f of negative 1. That means we're going to wrap our variable in parentheses and replace x with negative 1. 5 times negative 1 plus 3. 5 times negative 1 would be negative 5, plus 3 would be negative 2. Now the second time we're going to replace x with positive 1, replacing the x with positive 1. 5 times 1 plus 3 would be 5 plus 3, which would be 8. And now we're going to replace x with a plus 1. So we have 5 times a plus 1 plus 3. When we distribute the 5, we'll have 5a plus 5, because 5 times 1 is 5, plus 3. And when we combine the like terms, we'll have 5a, and 5 plus 3 is 8. So we'll have 5a plus 8. One more example. F of x is equal to negative 3x squared plus 5x minus 1. So we'll wrap our variable in parentheses first and then copy it down. Negative 3, we're putting in negative 2 where the x is, plus 5 times negative 2 minus 1. So now we have negative 3, and negative 2 squared would be negative 2 times negative 2, which would be positive 4. 5 times negative 2 would be negative 10 minus 1, which gives us negative 3 times 4 would be negative 12 minus 10 minus 1. So we have negative 12 and negative 10 would be negative 22, and one more negative makes negative 23. Then we're going to do f of 0. Negative 3, I'm replacing the x with the 0. Negative 3 times 0 squared plus 5 times 0 minus 1. Or we have negative 3 times 0 squared is 0. 5 times 0 is 0 minus 1. Or we have 0 plus 0 minus 1, which is negative 1. In our last example, we're replacing the x with an a. Replacing the x with an a. Let me move it back up to where I can see it. Replacing the x right here with an a. So we will have negative 3 times a squared plus 5 times a minus 1. This is Jo Karen Hudson. Thank you, and have a wonderful day.